as long as you don't poke each other with a ruler or throw like egg in each other's eye, you don't have to wear goggles today. But you will need your calculator. So if you didn't bring a calculator, I've got something you can use. So today we're going to be talking about density, again, like we talked about in lecture yesterday, and I'll kind of remind you what that is here in a minute, and we'll be talking a little bit more, finishing up that part in lecture tomorrow about density. But you're going to be measuring some things, and kind of like we talked about in lecture, when you measure things, we're actually going to make you measure between the gradations. So I know it sounds kind of trite, but if you've had a chance to look over what you're doing first, you're actually getting the 3 dimensions of these blocks, color of your choice. So things that you're going to need are pretty much over here. The blocks are over here. So I don't care what you call length, width, and height, okay? But this is what you're going to write down on your data sheet. So your rulers, if you're like me, I always have to concentrate when I'm working with rulers. So kind of orient yourself. So you're going to be using the metric side, okay? Since the gradations are actually every 1/10 of a centimeter, which would be a millimeter, basically you're going to report to the nearest, how do I say this? These little lines right here, that is 0.1 centimeters. So like for instance, this one, if the blue line was like what you were measuring, I would call it 1.08 centimeters because it's not quite to the 1.1. Okay, so that's kind of what I'm going to be looking for. Okay, so that format. All right, so you're going to measure the 3 dimensions. And part of what this lab is to do is to kind of get you used to how you're supposed to work physical science problems. And my mantra is going to be show all calculations. Hey, Jessica. Include the units, okay, and round correctly. Now, we spent a little bit of time yesterday in lecture talking about how do you round. And it depends on what you're doing. If you're multiplying like you're going to do to get the volume is length times width times height. You're going to round according to sig figs, okay? So in the second box, I think it's the second box, in the box at the bottom of the first page, actually I'm going to want to see this. So you're going to put whatever your length was, whatever your width was, and whatever your height was. And I'm going to be looking for 2 decimal places for each one of those measurements. Okay? So you guys are working in groups. Feel free to kind of check each other. The rulers are over here. I got plenty of rulers. Okay? So you're going to get the volume. Sorry. You're going to get each of the dimensions and you're going to multiply them together to get the volume. Okay. The other thing you need to get the volume on. Oh. Here's just my reminder to show all of your work. Now, when we multiply numbers like with units like this in physical science, it's basically, to me, I think of gathering the numbers together, throwing them in my calculator. Sometimes I'll even write down calc, like I showed you yesterday, and I say calc is equal to, and I write it down, because I'm going to round that. And then don't forget, we also have to tack on units. So units are along for the ride. Sometimes units will cancel, and we'll talk about that later on, probably next week. But in this case, all of these units combined together, centimeters times centimeters times centimeters, of course, is centimeters cubed. So we're going to be looking for that. So kind of getting you used to, if you're not used to working problems. All right, the other thing you're going to be getting the density of, thus you need the volume of, is a little bit harder, okay? So you're going to be getting the volume of this rubber stopper, okay? And you'd be like, well, it's kind of a weird shape. I can't just take length times width times height, bless you, like I can for my block, okay? We're going to be using the old Crisco method. And anymore you can buy Crisco in like the, you know, the nice little bars, Crisco or shortening or whatever, but you used to buy it in a tub. And if you needed a cup or a half a cup of Crisco, lard basically, you would grab your cup measuring. If you need a half cup, okay, of lard, you would fill your cup with a half a cup of water, and then you would dump in lard, okay, until it came up to the 1 cup. Okay, so you add a half a cup of water, you add lard to a full cup, you've displaced a half a cup, so that must mean you have a half a cup of lard in there. So it's the Crisco method. So basically what you're going to do is probably your 50 mil graduated cylinder will work best. You're going to go up to about 25 milliliters. Now it doesn't have to be exact, but you do need a fix on what that volume is. I got bubbles in there. I don't want those bubbles. But again, you need to estimate between gradations, and if this is the sort of graduated cylinder you use, let's see, let me think. It looks to me like I got 20, looks to me like every division is 1 milliliter. So if that's the case, what I'm going to be looking for is if it's 1 milliliter, you can estimate between, so that's the point X, like 1/10 of a milliliter. So kind of your format for that one would be X dot X milliliters. So I'm going to be looking for something in the tenths place there for that. So you get the volume without the stopper. You put the stopper in, which would be your Crisco. Okay, you try to kind of be careful, watch out for bubbles. Okay, I got a few bubbles there. I'll try to get rid of those if I can. And then look for basically the water that was displaced. So we're going to get to the water that was displaced by now writing down this new volume and then subtracting the two. Okay, and then there's a little thing at the top for you to do that. But my point here is write all of your work, show your subtraction. I know it's pretty straightforward. But now you're going to round according to decimals since you're subtracting, okay? So that's important. So that will give you the volume of your cute little black stopper. The black stoppers are up here. They kind of blend in. Here's the black stoppers. So now we have the volume of the block, okay? And we have the volume of the stopper. What I've missed actually in my preparation is somewhere in there you need to get the mass of both. The mass, getting the mass isn't too fancy. Okay, you are going to, for the first time, use our balances. We've got some nice balances over here. These read to the nearest 0.00 to the nearest 3 decimals of a gram, so that's kind of cool. Most balances have a tare feature, and the tare feature here is, it's kind of like the yes part. It says right in the middle. If you hit that, you'll see it go blank for a minute, and it's basically torn out. Okay, and then it's zeroed out, torn out and zeroed out are the same thing. And our scales are pretty nice. They've got these nice kind of air to kind of stop air currents from going. So I want to put my thing in there and close it up and let it settle down and then read that back and write it down. That's my mass. Now, as I've been doing this, you think maybe you want to get the mass of your stopper before you get it wet? Maybe. Either that or pull it out and dry it real good and get the mass. Okay. So you need the mass of those two objects. Then you're ready to knock out the density. So the density, remember, is basically kind of how fluffy or how kind of compact matter is. So density is a division problem. It's mass divided by volume. Remember, the symbol for density is not the capital D. It's actually the Greek letter rho. Okay, so density. So we're going to do a division. Be sure you show your work there. Okay. Notice then that it's all about units. Units are very important. So what's happened when you've gotten the volume of these two objects is the volume of the block is in centimeters cubed, because it's centimeters times centimeters times centimeters. The volume of your black rubber stopper is in milliliters, because you did the Crisco method and this is milliliters. They're both great volumes, and like we talked about in lecture yesterday. Units of density are always mass per volume. Units of density for your block will be grams per cubic centimeter. Units of density for your rubber stopper will be grams per milliliter. Both awesome. So since we're dividing here, don't forget to round according to significant figures for that one. Okay. So then the last part. The last part is where, like I talked about in lecture, you are going to take a mixture. You're going to separate that mixture into its components. Now, some mixtures are harder to separate than others, okay? This mixture is pretty easy. Here's your mixture. It is a heterogeneous mixture. I might have some for lunch if there's any left. There are 4 eggs in here. I'm not the cook in my family, so honestly, I always have to ask my husband, now, how do you boil eggs? Oh, that's terrible. Okay, so here's our mixture. You're going to want to separate it into its 3 components. Now, this one's kind of damp, and I bet they all are. I would take a paper towel and wipe it off. It might give you better results, okay? Because that moisture can kind of go throughout your experiment. Because basically, one of the first things you're going to do with your mixture is to get a weight on your mixture. By the way, when somebody gives you by definition percent, like if they say, oh, it's 25% sugar, then that means if you have 100 grams of that solution, you will have 25 grams of sugar. That's what that means. Okay, but if you're like today, if you are in all about coming up with the weight percent of each of these components, now there are 3 components. There's the shell, the white, and the yolk. If you're all about that, then actually what you're going to do is you're going to measure the mass of the mixture, which is the whole egg, nothing but the egg. So you're going to weigh the whole mass of the mixture, grams of mixture, okay? And then you're going to separate it out, and then you're going to measure each of the masses of the components. Now, of course, ideally, the masses of your components add up to the masses of your mixture. It doesn't necessarily work that way. Okay, so how do you get a mass of this one? And actually, I think that mass kind of goes on the top of your data sheet for this part. Well, these are the weighing boats for the mix for the components. There's an S for shell, a W for white, a Y for yolk already on there. I probably would grab one of these, okay, put it in here, tear it out, okay, and then I would, once it's done thinking, torn out, I probably would kind of carefully put my egg in there and hope it didn't roll off. That's pretty good. That's probably how you get the mass of the whole mixture. So now to get the masses of the components, we are going to actually do something that is oftentimes done in chemistry or physical science. Before we separate it, we are going to go ahead and get a tare weight on each of these. So there's a place on your data sheets, okay, that says basically the weight of the container. This is the weight of the container. So get a good weight on these, okay, write that down, and then go ahead and see who's the best at separating your eggs out. Now there is a knack, as you probably know, to boiling the eggs so they peel easier. So we'll just see how I did. I don't know. Okay, so then you're going to separate it out after you have a good tare weight on these into your 3 boats. And then you're going to weigh those boats back. Okay, you weigh them empty and you're going to weigh them with their contents. Then there's a place on your data sheets to do a subtraction. And by subtraction, you can come up with the mass of each of your 3 components. Mm-hmm.
It says mass of component and container, so should you put the component with the container, don't tear it out.
Right.
Tear it out before you put
Yes.
the container and the component.
Exactly.
Okay.
Exactly. You're going to tear it out. You're going to tear it out now, weigh the empty thing, and then leave it torn out, or tear it out again if you want to, but then tear it out and then weigh back with the component and the container.
Okay.
Exactly what you said.
Okay.
Exactly what you
So
said.
you want to tear it out before you put the component in the container, or do you want to tear it out before and then put both of them together in there?
The latter. Yeah, the latter. You tear it out. Yeah, yeah. The only time you're going to, if you want to, and I don't mean to confuse you, but the only time you're going to tear out it with the container on there is to weigh your whole egg.
Okay.
Yep, yep, yep. Very good. So then at the bottom of your data sheet, you're ready to, for each of your 3 components, go ahead and come up with a weight percent of each of the components. And it's going to be a division problem, so since we're dividing, we count significant figures and round according to that. Okay, so that should be fine. And one of my last little things is, the cool thing about this sort of problem is actually you can check how well you did, or if there was something kind of inherent to your experiment that, you know, you would expect, if you add up the percentages of all 3 components, you would expect it to be 100, yeah. So we'll just kind of, if you don't mind, probably I'll kind of ask you to kind of sum those and see what you come up with. Okay? Any questions? When you're done with this egg, what I'll do is I'll have like a little trash sack underneath the middle hood where the eggs are, so we can kind of gather the stuff. Okay? The nice, lovely, smelly stuff. And I hope everybody ate before they came. Cool. I'll catch you on the other side. That's it.